When we talk about the nearest galaxy, it's important to specify what we mean. It's like asking for directions to the nearest coffee shop. Are we talking about a cozy cafe a block away or a Starbucks in the next town over? The universe, like our taste for caffeine, comes in different sizes. The Canis Major Dwarf Galaxy, a cosmic cloud of stars, holds the title for closest galaxy to our Milky Way. This dwarf galaxy is a mere 25,000 light-years away. Now let's talk about Andromeda. This spiral galaxy, a glittering pinwheel of billions of stars, is the nearest galaxy to our own. Andromeda sits at a distance of 2.5 million light-years, significantly farther than our diminutive neighbor, Canis Major Dwarf. So, which galaxy wins the nearest title? It depends on your definition. Canis Major Dwarf takes the crown for proximity, while Andromeda, a galaxy more like our own, claims the title of nearest major galactic neighbor. 25,000 light-years. It sounds like an insurmountable distance, and by our current standards, it is. To put it in perspective, 1 light-year is the distance light travels in a year, nearly 6 trillion miles. Even if we could build a spacecraft that traveled at the speed of light, a feat currently beyond our technological reach, reaching Canis Major Dwarf would still take 25,000 years. Let's be a bit more realistic. Our fastest spacecraft to date, Voyager, zips along at a speed of about 17 kilometers per second. At that pace, a journey to Canis Major Dwarf would be a multi-generational affair, lasting a mind-boggling 749 million years. It seems our cosmic neighbor, though relatively close in the grand scheme of the universe, remains frustratingly out of reach for now. Andromeda, a swirling mass of stars, gas and dust, is a sight to behold through a telescope. This majestic galaxy, much larger than our own Milky Way, is on a collision course with us. But don't panic, this cosmic merger won't happen for another few billion years. Traveling to Andromeda poses an even greater challenge than reaching Canis Major Dwarf. At a distance of 2.5 million light-years, even a beam of light, the fastest thing in the universe, takes 2.5 million years to make the journey. If we were to hop aboard a hypothetical spacecraft traveling at a mere 0.01% the speed of light, a speed we're not even close to achieving, reaching Andromeda would still take a staggering 200 million years. It seems visiting our galactic neighbor will remain in the realm of science fiction for the foreseeable future. Section 4. The present and future of spacecraft stuck in first gear? Our current spacecraft, marvels of engineering though they are simply not up to the task of intergalactic travel. Voyager 1 and 2, our most intrepid explorers, have barely dipped their toes into interstellar space, the vast region between stars. These spacecraft, launched in the 1970s, have provided invaluable data about our solar system, but their speed is a limiting factor. At their current pace, they would take tens of thousands of years just to reach the nearest star system, Proxima Centauri, let alone another galaxy. Section 5. Bridging the gap dreams of warp drives and generational ships. While the vast distances between galaxies seem insurmountable with our current technology, scientists and science fiction writers alike have dreamt up some intriguing possibilities. One concept, often seen in science fiction, is the warp drive. This hypothetical technology would allow spacecraft to bend space-time, effectively creating shortcuts between distant points in the universe. While warp drives remain purely theoretical, the idea continues to capture our imaginations. Another concept, perhaps more achievable in the long term, is the generational ship. Imagine a massive spacecraft, a self-sustaining ark carrying generations of humans on a journey spanning hundreds or even thousands of years. While fraught with its own set of challenges, the generational ship offers a potential, albeit incredibly long-term solution to the problem of interstellar travel. The journey to another galaxy is a daunting prospect, one that will likely require breakthroughs in physics and engineering that we can only dream of today. But the human spirit of exploration, our innate desire to push the boundaries of knowledge and reach for the stars, suggests that we will continue to seek ways to bridge the vast cosmic gulfs that separate us from our galactic neighbors.